Hello, good day. My name is Bonifacio Rosario. I'm actually presenting the course project on statistical analysis with software application. I would like to present to you the presentation that I have done for the start for the A for the definitions and along with the discussion as well as the statistical analysis problem calculation. Okay, I'll show you this one. Okay, this is course project under CS6264 analysis, statistical analysis with software application. The first is actually number one, define statistics and statistical analysis. So statistics is derived from a Latin word status, meaning state or condition. According to English Advanced Dictionary, statistics is a branch of mathematics that deals with analysis and interpretation of numerical data in terms of sample and population. Statistics as well is a science that is concerned with the collection, compilation, presentation, analysis, and collection of numerical data. So statistical analysis while statistical analysis is the organization and analysis of quantitative or qualitative data using statistical procedures, including both descriptive and inferential statistics. It is the science of collecting, exploring, and presenting large amount of data to discover underlying patterns and trends. So, in other branch, many definitions, statistics is a branch of science that renders various tools and analytical techniques in order to deal with a huge extent of data. In example terms, it is the science of assembling, classifying, analyzing, and interpreting and manifesting the numeric form of data or making inferences about the population from the pick out example or sample data that can be used by business experts to solve their problems. Therefore, in the efforts to organize data and anticipate procedure trends depending upon the information, many organizations heavily rely on statistical analysis. While more precisely, statistical data analysis concerns on data collection, interpretation, and presentation. It can be approached while handling data to solve complex problems. More precisely, the statistical analysis delivers significance to insignificant, irrelevant data or numbers. There are some key types of statistical analysis, which are, in particular, statistical analysis is the process of consolidating and analyzing distinct samples of data to divulge patterns or trends, anticipating future events, situations to make appropriate decisions. The statistical analysis has the following types that considerably depends upon the data types. Types of statistical analysis. So there are 7 types of statistical analysis. First is the descriptive statistical analysis, which is used to describe the feature of data and shows or summarize data in the form of tables, charts, and graphs. Inferential statistics analysis, it is used to study the relationships among variables in data and helps in making predictions, conclusions, or generalization about the whole population. The next one is the preventive analysis. It is used to define the likelihood of future outcomes, behaviors, and trends based on recent and prior data by implementing approaches like statistical techniques and machine learning. The fourth one is the prescriptive analysis. It is the systematic study that examines the data to get a response of what should be done and assist in finding the optimal suggestion in decision-making process. The fifth one, the exploratory data, it renders a preview of data and assists in getting some key insights into it as it fully focuses on analyzing patterns in the data to recognize potential relationships. The sixth one is causal analysis, which is assists in understanding and determining the reasons behind why things occur or why things are as such as they occur. The seventh and the last one is mechanistic analysis. It is used to understand the exact changes in the given variable that can make changes in other variables while having the assumption that the whole system is affected by its internal elements. The next is to define data science. Data science is the science of learning from data. The sciences are focusing on answering specific questions about the world, while data science is focusing on how to manipulate data efficiently and effectively. The primary focus is not which questions to ask of the data, but how we can answer them. Whatever they may be, it is more like computer science and mathematics than it is like a natural sciences in this way. It isn't so much about studying the natural world as it is about how to compute data efficiently. It included in the data science is the design of experiments. With the right data, we can address the questions we are interested in, and for the poor data of experiments or poor choice of data we gather, this can be difficult. So study again design might be the most important aspects of data science. So data science is also related to machine learning and artificial intelligence, and again, these are huge overlaps. Perhaps it is actually not surprising since something like machine learning has its home both in computer science and in statistics if it is focusing on data analysis. It is also at home in data science. To be honest, it has never been clear to me when mathematical model changes from being blind old statistical model of becoming machine learnings in any way. The third numbers is actually differentiate between business intelligence and data science. Data science involves studying the historic trends and thus using its conclusion to redefine present trends and also predict future trends. Business intelligence Power BI is basically a set of technologies, applications, and processes that are used by the enterprises for business data analysis. Where perhaps the other easiest way to differentiate is to think of data science in terms of the future and business intelligence in terms of the past and the present. Data science deals with predictive analysis and perspective analysis, while Power BI or business intelligence deals with the descriptive analysis with our source from our given there on the research. So we have here based on the differentiation between data science and business intelligence. On the data science differentiation, data science is basically the field in which information and knowledge are extracted from the data by using various scientific methods, algorithms, and processes. It can thus be defined as a combination of various mathematical tools, algorithms, statistics, and machine learning techniques that were thus used to find the hidden patterns and insights from the data, which helps in the decision-making process. Data science deals with both structured as well as unstructured data. It is related to both data mining and big data. Data science involves studying the historic trends and thus using its conclusions to redefine present trends and also predict future trends. While business intelligence or BI is basically a set of technologies, applications, and processes that are used by enterprises for business data analysis. It is specifically used for the conversion of the raw data into a meaningful information which is thus used for the business decision making and profitable actions. It deals with the analysis of the structured and sometimes unstructured data, which pave the way for new and profitable business opportunities. It supports decision making based on facts rather than assumption based on decision making. Thus, it has the direct impact on the business decision of an enterprise. Business intelligence tools enhance the chances of enterprise to enter a new market as well as help in studying the impact of marketing efforts. Or next. So here, based on our research, it has been divided the factor, data science, and business intelligence. The based on the factor concept, data intelligence, it's in the field of uses mathematics and statistics and various other tools to discover the hidden patterns in the data, while business it is basically a set of technologies and applications and processes that are used in enterprise for the business analysis. Then focus, while data science, it focuses on the future, while business intelligence, it focuses in the past and present. For the data, the difference is it deals with both structured as well unstructured, while business intelligence, it mainly deals only with the structured data. On flexibility, data science is much more flexible as data sources can be added as per requirement, while on business intelligence, it is less flexible as in case of business intelligence data sources need to be pre-planned. The method, it makes the use of scientific method, while on business intelligence, it makes the use of analytic method. Complexity actually rather, it has the higher complexity in comparison to business intelligence, while business intelligence, it is much simpler when compared to data science. For expertise, the comparisons, its expertise is the data scientist, while in business intelligence, its expertise is the business user. For questions, it deals with the questions that what will happen and what if, while business intelligence, it deals with the question what happened. On tools, its tools are SAS, Big ML, MATLAB, Excel, etc. for data science, while the tools are Insight Squared, Sales Analytics, Clipfolio, ThruSpot, SciFi, TIDCO, Spotfire, etc. So that's the differentiation of the business intelligence versus data science. Next. Okay, so question is curiosity is not important in data science? Why? Well, for me, I believe that curiosity is the key for data science and its success, because such other skills such as mathematics and programming can be gained through experience, and though many courses that are found online. But main characteristic of data scientists should be curiosity. Thus, curiosity about finding insights from data and answering questions. So, why is curiosity is the main skill characteristic for starting a career in data science? From all experience, the only reason that made this pursue a certificate in data science was IBM Data Science Professional Certification was for curiosity for other senior data analysts nowadays. So curiosity is discovering new insights from the raw data because of the only way to improve something by measuring it. Okay, so to conclude that many data scientists weren't curious about data science, if then they wouldn't have started this certificate, and therefore there wouldn't be achieved other skills. So I believe curiosity is a must for starting a career in data science, and it's actually also important to have this as a skill in order to actually study and learn data science effectively. And this way I would acknowledge to the credit to the owner, which I actually get this information from the Lincoln Data Science by Mr. Mustafa Isidin. Okay, he's a senior consultant for data analytics. Next, define algorithms. So actually, the definition of algorithm is a specific and logical procedure to be followed in order to achieve specific results or to solve a math problem. An example for the basic algorithm is the procedure in math that states how to add double or more digit numbers together in order to achieve the correct answer. So there are lots of definitions which actually I gathered. So, but there are types of algorithms. Mainly algorithms. We have divide and conquer algorithm. We have greedy algorithm. We have dynamic programming. We have randomized algorithm. We have merge sort. We have backtracking, quick sort, and brute force search. These are the types of algorithms that you can be able to look more deeper in this purpose. So, algorithms is a sequence of instruction for completing tasks. In order to the sequence is significant. In computing algorithms tells processors what to do. So it's algorithms from input set of rules obtain the expected output from the given input, then the output again. So when we follow a recipe to bake a cake, we're in effect executing an algorithm. The inputs are the ingredients. By obeying the algorithm, do such and such to the inputs, we can create output, the cake. So mathematicians write algorithms for formulas such x plus y equals z. In this example, inputs are x and y, and the output is z. In computing, the variables that algorithms manipulate are in storage locations. A simple algorithm in computer might be like go this. Take the quantity in location A1 and add it to the quantity in location A2. Store the result in location A3. So the origin of the term algorithm, the father of algorithm, was that Persian mathematician and astronomer Mr. Muhammad ibn Musa al-Qasri. He was born around at the end of the 8th century and died around the middle of the 9th century. So historians believe that al-Khwarizmi is the major achievements was bringing Hindu-Arabic numerals and algebra into the European market. The next, what problem would you solve with an algorithm? There are lots of categories that algorithms can be able to solve, but based on my research, the following problems could be solved with algorithms as follows: dealing with text searches, differentiating words, determining whether an application will end, creating and using one-way function, multiplying really large numbers, dividing a resource equally, and reducing edit distance, calculation time, and then solving problems quickly. There are lots more. So you can dig algorithm is very, very important. This actually current society we have. So the next, actually, number 7 is statistical analysis software. Statistical software are specialized computer programs which actually you can collect, organize, analyze, interpret, and statistically design data. There are two main statistical techniques which help in statistical data analysis. One is the descriptive statistics, and the other is inferential statistics. Descriptive statistics actually are crucial. Descriptive statistics organize data from sampling using indexes, while inferential statistics draw a conclusion from data that is random variant. So, statistics are crucial for organization. They provide factual data, which is critical in determining trends in the marketplace so that businesses can compare their performance against their competitor. The benefits of statistical analysis are: statistical analysis allows businesses to make crucial decisions about projects. It helps identify trends in the marketplace that can determine whether a project is right to invest in or not. Second, business statistics helps project future trends for better planning. If you are considering risk factor for a specific project that your company wants to roll out, when statistics are necessary. Okay, in this discussion, I added the 10 best statistical analysis software for 2021, which actually available in the market. So we have the max start. These are the data here, and I will show you the definitions. So the MaxStat, this is a very easy to use and affordable statistics software available online. 3 easy steps are required to finish the statistical analysis within a single dialog box, since it provides step-by-step analysis and is handy for students and young scholars. Okay, so the features, you can see the features. If you are not a professional statistician, MaxStart helps you to opt for the best statistics tool for your requirements. So you just have to give information about their data, and MaxStat will automatically choose the best statistical tool. MaxStat is very easy to understand, and the results you get at the end of its analysis is easy to understand. You don't have to have an expert to interpret the result scientifically. The second one is the wizard mock. Wizard mock is no typing or programming is required on this data analysis. So any professional can start directly the survey with the help of wizard mock. The predictive models help to make the business choices easy. The features, Wizard Mock provides you a simple graphical results that will help you understand and analyze the result easily. It can predict the results from one or more selected options. Wizard Mock can specific predictions after creating a predictive model with the help of sliders and pop-up buttons. The next one is the ACA-STAT. ACA-STAT is one of the best statistical analysis tools available online, and it analyzes data to the very simple statistical tools. It does a statistical analysis rapidly and make it simple. Next, the fourth one is NCSS. A large number of statistical and graphical tools to analyze data are available on NCSS software. It provides facilities like organized documentation, free training videos, and a 24/7 email support. The fifth one is the statwing, which is one of the fastest statistical tools available in the market. Users can perform tasks 5 times faster than statwing than they would be in MS Excel or other statistical tools such as R or SPSS. The sixth one is the XLStat, which is the statistical software which has lots of features to meet user needs and is compatible with Microsoft Excel and can be used on PC and Mac. The seventh one is the Stata. Stata is a unified software which provides you with a complete package required on data analysis, management, and graphics. Is one of the most important software online for statistical analysis. The eighth is IBM SPSS. It is an analytical software from IBM. It provides numerous statistical analytics such as text and entity analysis, automated modeling, and decision management and development. The ninth one, the SAS, is a perfect for traditional analysis of variance and linear regression and meets both specialized and enterprise-wide statistical needs. And the 10th one is the Minitab, is one of the best statistical softwares available online. More than 90% of Fortune companies and around 4,000 colleges and universities around the world use Minitab to create and analyze data. Okay, so that's the end of the part A. So the next one is the part B, which is a statistical analysis practice problem solving, and then I need to demonstrate this on solving the scenario here that you grow 10 carrots from your backyard farm and measure the length of each carrot in inches, and the data are as follows. So it's given here carrot 1 to 10, and then the length corresponding is we have the 9 for carrot 1, 6, 5, 4, 12, 7, 8, 11, 9, and 3 respectively. So the findings is, the questions is, find the following this under descriptive statistics, find the average mean length of the carrots, sample variance, and then sample standard deviation length of the carrots. Okay, so in order to find, we need first to determine, we need to find first the mean. So the mean, to find the mean, this is the formula that we need to add all the length of the carrots: 9 plus 6 plus 5 plus 4 plus 12 plus 7 plus 8 plus 11 plus 9 plus 3. That's the corresponding from the 10 carrots that we have. So it is actually a total of 74 over 10 in order to find the means, and the answer is 7.4. Now, to find the standard deviation, we have 5 steps. As the 5 steps is, step 1, we need to find the mean of the numbers. As discussed earlier, that we just added the number of length of the carrots over the number that we have 10 carrots. So 74 over 10, then 7.4 is the mean. That's the first steps in finding the standard deviation. Second steps in finding the standard deviation is, for each number, calculate the deviation between the number and the mean. So we have number here is x. So 9, 6, 5, 4, 12, 7, 8, 11, 9, and 3. This is the corresponding length of the carrots, 10 carrots that been planted. So in order to get the number, each number of the deviation, we need to minus it from the mean. So the number minus the mean equals the deviation. Okay, so we hereby 9 minus 7.4 equals 1.6. 6 minus 7.4 equals negative 1.4. 5 minus 7.4 equals negative 2.4. 4 minus 7.4 equals negative 3.4. 12 minus 7.4 equals 4.6. 7 minus 7.4 equals negative 0.4. 8 minus 7.4 equals positive 0.6. And then 11 minus 7.4 equals 3.6. 9 minus 7.4 equals 1.6. And then the last one is the 3 minus 7.4 equals negative 4.4. Now, the third step is we need to calculate the square of each deviation in step 2 and find the sum of this squared deviation. So from here, we got the number. We have the calculated the deviation of the number. We found out already. Then, in order to calculate the square of its deviation, we need to find the sum of this squared deviation, this one. So, in x equals the deviation that we found actually on step number 2. So therefore, 1.6 squared, or 1.6 times 1.6 equals 2.56. Negative 1.4 times negative 1.4 equals 1.96. Negative 2.4 times negative 2.4 equals 5.76. Negative 3.4 times negative 3.4 equals 11.56. 4.6 times 4.6 equals 21.16. Negative 0.4 times negative 0.4 equals 0.16. zero point 0.6 times zero point 0.6 equals 0.36. 3.6 times 3.6 equals 12.96. 1.6 times 1.6 equals 256. Negative 4.4 times negative 4.4 equals 19.36. When I add this one, it will goes me with the sum of the squared deviation of 78.4. Okay, so let's go now to the step number 4. To find the standard deviation in step number 4, because we have the sample of the number 10 values, divide the sum of 78.4 by number minus 1, which is 9. So 78.4, we're going to divide it to 9, so equals 8.71. Okay, that's our that's the values of the deviation. Then in step 5, so that is the solution. We can find the standard deviation of the sample is square root of 8.71, and to the nearest 100, the standard deviation is 2.9513. That's our calculations on that sense. So we go back to this the first one. So what is actually been given? So the mean is 7.4. The sample variance is 8.71, and the standard deviation after the calculation is 2.9513. So that's the how we actually obtain from the carrots 1 to 10 with the length respectively, and how we get the answer. So this is based on my research. So, and thank you very much, and I thereby have submit it now with the link of the YouTube video that I'm going to submit accordingly. Thank you and have a nice okay, thank you sir for watching this presentation, and have a nice day. Thank you.